It's an honor to be here with you today. Thank you, Chief Lyons, for sharing your inspirational words and for sharing this bit of our history. I just feel a little bit humbled in standing here with it, so thank you for sharing that. And I'm sorry that Rachel had to leave already, because just seeing all the children involved in growing crops again, that brings me hope, and it made me smile. So I am with USDA, and USDA will be celebrating its 150th anniversary next year. We were begun by President Lincoln, who called us the People's Department. That's what USDA was designed to be. And a couple of years ago, we started an initiative called the People's Gardens. And so at various different USDA installations all over the country, and in fact in other countries as well where we have USDA installations, we've been planting gardens. Some of them are flower gardens, some of them are vegetable gardens, but you can even go, if you're here on the mall and you go over to the USDA buildings, you can see our People's Gardens there. So please enjoy them. They belong to you. I am in the REE mission area. That's Research, Education, and Economics. So I'm one of those people that comes and says, I'm from the government and I'm here to help. And I really do mean that. We are a mission-oriented, problem-solving agency, the Agricultural Research Service. We have 100 locations in the US, 5 worldwide, primarily aimed at biological control. We have 2,500 research scientists aimed at solving the problems of agriculture. We're divided into 4 divisions: natural resources, where we have water, air, soil, and our issues such as climate change; crop production and protection; animal production and protection; and then human nutrition and food safety. I'm in the group called Crop Production and Protection. Within that group, we have various different areas of research that I think come to bear on the overall issue that we're talking about here today. The first is our gene banks. We have collected germplasm on all kinds of crops and plants worldwide through our partnerships with other countries. And we preserve and protect that germplasm for the use of all of us. That germplasm is there and can be requested by anyone for the use in research without cost. We don't even charge for shipping. There are databases online where you can search and you can find out what's all in our collections, and you can make those requests. Those requests come from university researchers. They also come from backyard gardeners who like to do their own plant breeding. It's all there for the use of common good. We do a lot of breeding, genetics, and genomics work. In fact, yesterday we had the workshop. It's time in our 5-year cycle of national programs for our plant breeding national program to begin its next cycle. So we start that by bringing together customer stakeholders and asking for their input. What are the challenges that you're facing that our research programs might be able to address? We also have national programs in disease, insect, and weed management. And I'm looking at these beautiful greenhouses here, and I know greenhouses never have any diseases in them, and they never have any insects in them. So in fact, with those wonderful climates that are excellent for growing the crops, sometimes we're also excellent at growing the things we don't want to. And we have research programs that are addressing different ways of controlling. We also have, especially in a greenhouse situation like this, pollinator issues. You know, your vegetables that won't set fruit unless you have your pollinators in there. We have a whole section of our research programs on pollinators, both conventional and or traditional, and some of the non-traditional ones. So one of the things that we're looking at is we want to have an available, affordable, safe food supply. Now that means that with our growing populations, one of the things we might want to do is expand when we can grow our crop. So we have researchers that are looking at high tunnel production. We have a researcher who is breeding new strawberry varieties and looking at the high tunnel. So she actually, through the whole summer here in Maryland, was producing strawberries. Remember when we had those 100+ degree days here? She still had strawberries, and they taste good. I have another researcher that's looking at the other end of the spectrum. He's got these high tunnels out on the eastern shore of Maryland, and he was producing in January and February last year. So if we can create the kinds of production systems where we can grow them locally, and we don't have to ship from California. California doesn't much like me saying those kinds of things, but they've got a big market already anyway. So expanding the growing season, or expanding the range of where we can grow them. We're doing some other work where we can then develop production systems so that we're growing blackberries where we haven't been able to grow blackberries in the past. So all of that are some of the kinds of things that USDA is doing on your behalf. One of the things I wanted to talk to you about a little bit today is this thing called Virtual Grower. This is a piece of software that some of our scientists developed, and let me just read what they say it does. Virtual Grower can not only identify those savings through different greenhouse designs, but predicts crop growth, assists in scheduling, makes real-time predictions of energy use, and see the impacts of supplemental lighting on plant growth and development. In other words, the software can be used as a safety net to allow users to experiment with what-if scenarios on the software before you try it in your greenhouse. This is freely available. It's available on the website. I brought a few copies of it here. I also brought copies of one of their recent articles. This is version 3.0, which was just released in August. It's got some updates. It's now available on the Macintosh as well as on PCs. And so for as many copies as I have here, if there's people interested in it, I'm happy to give them to you. And I have the copies of the articles here as well. I did bring printouts of some PowerPoint slides, if anybody is interested in those. But part of what this did, it's mostly aimed at flowers right now, but our intention is to expand that into some of the vegetable production systems as well. So you can look at fuel types, you can look at building materials of the greenhouse itself. You can even now in the new version track backwards. So instead of saying I'm planting on April 3rd, when is my crop going to be ready? You can say I want my crop ready for Mother's Day. When do I have to have planted it to get there? So there's some fun and interesting things in there. Another thing that I would like to just briefly touch on, and hopefully I don't offend anyone here, because it has to do with transgenics, genetically modified organisms, and some don't want to use those, and others do. One of the things that we have done with one of our research groups, and it was in collaboration with some work that came out of, I may say this wrong, Umeå Plant Science Center in Sweden? My hometown. It's your hometown. Okay, they and an American team found this gene in the poplar plant that can speed up. So when we're breeding for new plums and apricots and nectarines and things like that, usually it takes us 4 to 7 years in each generation. So you make a cross, then you have to wait 4 to 7 years to see how the fruit actually is there. We can now go through that generation in 1 year. We can go seed to seed in 1 year. So we put that in there one time. Then we do the regular conventional back crosses to get whatever the traits are, whether it's disease resistance, whether it's increased sugars, using traditional breeding. And then in the last cross, when you get that last population out there, because it's a segregating population, so part of the population always will not have that transgenic gene in it. So in the end, when you've got all of the good traits in there, which you were able to do much more rapidly because it's a 1-year generation time, then you select the one that doesn't have the transgene in it. So your final product is not transgenic. You just got to it faster. Now that last one, you're going to have to take and plant out in the field, and it's going to take you 4 years before you can check its fruit. But you got to it instead of 20 years in 6 or 7 years. Now, if you don't mind the fact that it is transgenic to begin with, then you have another option even for the greenhouse production. Because these plants, and I have some of these handouts of people, I don't have enough for everybody, but if some are interested, these plants with this transgene in it have flowers and fruit on them simultaneously throughout the growing season. And you can see here, this plant, or here, you can see it in a greenhouse. It stays as a shrub. And yet it produces wonderful tasting tree fruit. so you can produce it in a greenhouse. So those are just a couple of the things that we're doing, and I know we needed to be very quick, so I'm going to wrap up there, and I'll be happy at the reception time to chat with anybody who might be interested in some of this later, or if you want to come grab a CD, happy to have you do that. Thank you for the opportunity to be here.